In 10 years, we would like to buy a boat that will cost $500,000 at that time. If savings can earn 4%, since it's not specified, we assume this is the annual rate. How much will we need to save each year starting at the end of this year in order to reach your goal? So this is the type of questions where we are saving towards a target amount. And the saving is done by these regular payments, regular cash flows that we save in an account earning a certain interest rate. So this makes this an annuity problem, right? Because we are saving a certain amount, a regular amount, at regular intervals. So when we have an annuity, the first couple questions we need to ask ourselves is, what is the frequency of these cash flows? These are annual, saying save each year starting at the end of this year. So we're going to use our annual annuity formulas. The second question is this an ordinary annuity with end of period payments, cash flows, or is it beginning of period annuity due? And here it is explicitly mentioned at the end of this year, starting at the end of this year. So that means we are looking at an ordinary annuity, so we are going to be using our ordinary annuity formulas. Even if it wasn't mentioned, it would be implied that it would be an ordinary annuity. If otherwise it's said starting today or starting at the beginning of this year, then it would have been an annuity due, which would have been a different formula. All right, so we have a regular annual annuity in our hands, and then we are given what it accumulates to. Right, we are given the $500,000. So when we have an annuity and when we are trying to find the cash flow, so this is a solve for cash flow problem. And the big question, as mentioned in the hint, is whether we must know either the present value of that annuity or the future value of that annuity. And again, that dictates the formula we're going to use. So what do we have here? So the way you figure that out is whether you are given the amount that comes after the cash flows, in which case that would be a future value, or the amount prior to the cash flows, in which case you would have the present value. Here, when you're saving towards a target, right, it is naturally going to be the amount at the end, the balance at the end. That's going to be the future value of that annuity. So $500,000 here is that future value of that annuity, with the annuity cash flows being the annual savings that we are putting away. That's earning 4%, right? So this is an FV annuity setup. Now, what would a PV annuity setup would look like? For example, if you were given an amount today that you're, say, withdrawing out of, so those are withdrawal problems, so you're making these regular withdrawals, that would be a present value of annuity setup. Okay, so this is future value of annuity. So let's write the formula. FV annuity, right, equals cash flow times 1 plus I raised to n minus 1 divided by I. So that's our formula. So now what we have here is we know the amount our savings are accumulating to, which is $500,000. We know the interest rate, and we know how many payments, how many years there are, and that's going to be 10. All right, so we can put everything here. 500,000, we can plug in everything except the cash flows, which is what we are trying to figure out. Cash flow times 1 plus interest rate is 0.04 raised to 10 minus 1 divided by 0.04. All right, and we are trying to solve for cash flow. So how do we solve for cash flow? Let's first figure out this number here. And then we can divide both sides by that to find the cash flows. All right. So what I like doing in these annuity problems, I like starting with the parentheses, the term inside the parentheses. So 1 plus 0.04 raised to y to the x 10 minus 1. That's the numerator. Divide by 0.04. That's 12 and some change. All right, so what we are doing is we are multiplying each annual cash flow by 12, and it's going to accumulate to 500,000. Now, this is an interesting number because we are putting 10 of these cash flows, but we are ending up with 12 of them. Why the difference? Well, it's the interest, 4% per year for 10 years, right? Instead of at 0%, we would have 10 cash flows inside the account, just staying there, right? But with the interest, we are ending up with 12,000, 2 extra cash flows, thanks to our money earning interest. All right. So now I want to divide both sides by this number. So that's going to leave cash flow alone. So we're going to have 500,000 divided by this. It's going to give us the annual amount we need to save. So one way of doing that is I can store this, and then I can say 500,000 divided by recall what I sold, or recall the answer from the previous. So I can do that. Or I can do, I can say, this is the same thing as multiplying 500,000 by the reciprocal of this. Those are the same thing. Dividing 500,000 by this is the same thing as multiplying 500,000 by the reciprocal, 1 over this, right? So that's what I'm going to do, 1 over x, and multiply 500,000 by that gives me, and now I can round it, right? So I need to put aside $41,645.47 at the end of each year for 10 years, earning 4%. And I'm going to end up with $500,000 after 10 years.